We are not going to be graphing them today. We're going to be solving equations. There are two ways in which you can solve these equations. You can solve them algebraically, which is just with basic math, which you all know how to do, and you'll see that that's preferred. It is much easier than the other option, which is solving it graphically. When you solve it graphically, you have to draw two graphs and see where they overlap. We've done that before. You did that in Foundations 10. In Foundations 10, you graphed two lines and saw where they crossed. It was called a system of equations. We also saw it in Precalc 20, but in Precalc 20, we upped the ante a little bit and potentially had 2 points where they cross. We've done that before, okay? So that's the other option, is graphing them to solve where they cross. I'm going to show you how you would do it graphically just once. I'm just going to show you once, and you can decide if you want to do it that way or not. But then beyond that, I'm just doing it algebraically because it is so much easier. Okay, so I'm going to show you both methods, but you will only be required to solve them algebraically. If you want to do it graphically, that's your choice. Graphically, that's not a word. Graphically. Okay, so here we go. I want you to solve 16 over x plus 6 equals 4 minus x. So what you'll notice is you now have an equation with two parts to it, okay? On the left side, we have that rational function that we saw yesterday and the day before. We have 16 over x plus 6. But now I'm forcing it to be equal to something else. I'm forcing it to be equal to 4 minus x. So I'm going to show you how you would solve for x algebraically. And like I said, this is nothing new to you. This should be a breeze. To solve for x, whenever you have a fraction, step one for me is to get rid of the fraction or get rid of the denominator by multiplying each side by x plus 6. So I have to do it over here too. Now, this is where you have to be careful. On the left, they cross out. On the right, the way I wrote it on the right is deceiving because it looks like just the x would be sent in, but that's not the case. You are multiplying the entire right side by that x plus 6. So you need to put brackets around the 4 minus x, which means that we need to FOIL. First, outside, inside, last. We have 4 multiplications to do on the right. On the left, though, I only have the 16. How nice. Okay, on the right, 4 times x is 4x. Negative x times x is negative x squared. Negative 6 times x, negative x times 6 is negative 6x. And finally, 4 times 6 is positive 24. Okay, so they're in kind of a weird order. So what we're going to do now is we're going to subtract the 16. We're going to make my left side 0. And I'm going to also subtract the 16 to the other side. And now on my right-hand side, I'm just going to clean that all up. And I'm going to put the terms in order because I can see here, I'm going to get a trinomial. And I want trinomials in order. So I have a negative x squared all by itself. That's going to be my lead. I have 4x minus 6x. That's going to be a negative 2x in the middle. And then I have my two constant terms at the back. 24 minus 16 is positive 8. All right. So we've got ourselves a quadratic. You've been solving quadratics since Foundations 20. The first thing I'm going to do is factor out the negative. I do not like having a negative as my leading term, so I just take it out. I just have that negative out front. I think of two numbers that multiply for 8 and also add or subtract for 2. And I'm going to do negative 2 and a positive 4. And then you know the drill. You set each one equal to 0 and solve. So the symbols just flip. I have x equals 2 and x equals negative 4. Okay. The question also asked us to state restrictions. The restrictions come from the denominator always because you cannot divide by 0. So x would be allowed to be negative 6. So the way I write that or show that is I take my denominator and I say that is not allowed to be 0. And so I transfer the 6 over And there's your restriction. X is not allowed to be -6. So we've solved. Okay. Are either of my answers -6? No. So they're both good. Solution set, -4 and 2. Okay. I'm going to show you graphically, and I can pretty much all but guarantee that absolutely nobody will want to do it graphically after seeing what happens. Okay. So to solve it graphically, what you do is you take each part and separate them. So this was my left-hand side of the equation, and this was my right-hand side of the equation. And I kind of create separate equations for both of them, separate functions. And I'm going to graph those two separate functions and see where they cross. Okay, let's start with the easy one. If I just rearrange these two terms, y equals -x plus 4, that's in that y equals mx plus b form. We know how to graph that super easily. I know that will be a straight line. I know that my straight line will have a y-intercept at 4. And then I know my slope is -1/1. So my rise over run is down 1 to the right 1. That's the easy graph. Let's graph that. Okay, so I start where y is +4, and then my slope is down 1 to the right 1, down 1 to the right 1, and I'm going to extend it. Whenever you're trying to solve a system of equations graphically, you should always try to extend your lines as far as you can, because you never know where it might cross. So you want to have as much line as possible. Okay, this is why this is really gross, because now we have to graph the hard one. That's a rational function. We have to find the vertical asymptote, the horizontal asymptote, if there's points of discontinuity, yada, yada, yada. Why would you ever do that to yourself? I don't know, maybe you like graphing. Okay? Anyone think they're going to do it graphically yet? You're already unsold? Okay, so vertical asymptote, let's just do a refresh though. Vertical asymptote comes from your denominator, right? You set your denominator equal to 0 and solve. So we have a vertical asymptote at -6. That makes sense. That's our restriction. You cannot be at -6. You're going to have a wall there. Your horizontal asymptote is at y equals 0. The way I know immediately is because this equation right here is in the nice form. It's technically in that form. You have a number up top, you have an x with an h on the bottom. So technically my k is 0. And remember, your k is where your horizontal asymptote will fall. The other way is by comparing degrees, which we were doing yesterday. The degree on top is 0. You technically have x0 on top, compared with your degree on the bottom, which is x to the 1. Because your degree on the bottom is bigger, it's automatically at y equals 0. All right, then the way we graph these is we find our x and y intercept. And remember, these are quick, because if I make y equal to 0, and I can just like delete that denominator, because if I multiply by each side, x plus 6, my left side still stays 0. So when I do that, I get 0 equals 16. What does that tell me? You have no x-intercept then, because that's not possible. So that's okay. It just means you don't cross the x-axis. My y-intercept, make x equal to 0, so I have 16 over 6. That would be at about 2.7. Hey, this is why graphing is especially nasty. We're not even there yet. If I go and draw my asymptotes, okay, I would have an asymptote at x equals -6. Right there. And then I would have another one at y equals 0. Okay. And then my x-intercept for this guy is non-existent, but I do have a y-intercept at 2.7. So about there. Okay. This is a rational expression. Rational expressions have the arches, right? Bottom left, top right. So that means I have an arch in my top right, but I only have one point. Do I go like this Do I go more wide? What do I do? Like, how do I know where it goes? You know what I mean? So what you would need to do, you know, it has to cross one of these points we drew because we're trying to find the solution. Where does it cross? You know what you would do? This is why graphing's so gross and you're not going to do it. Is you would choose a whole bunch of those X values. And you would find, you'd plug them in. Whoops, you'd plug them into Y. And you would plot all those to get a perfect arch so that you can perfectly see where it should cross. Is anybody going to do this method? No. We know where it crosses though, because we did the answer. We know it crosses where X is 2. X is 2 right there on that point. And we know it crosses where X is -4. So up there on that point. So your arch would go like that. Okay. And it would overlap with that red line at those two spots. But the only way we would know that is by finding more and more and more and more and more points. So I trust no one's going to do it graphically. Let's move on and never do that again. Okay. Let's solve algebraically and state any restrictions. This guy, okay, so we're beefing it up a little bit because I have two fractions, okay? You always start the same way though. You want to get rid of your denominator. You don't want fractions. The problem is you have two denominators. You have x minus 1 and 2x minus 2. We did this in Precalc 20. In Precalc 20, what we did is we checked if we could factor any denominators first, which I can. This may come back to you a little bit. It's been a while since you've done this though. So if you have multiple denominators, factor them. I can't factor the x minus 1, but I can factor that. And that's important because you'll see that they have something in common. They have an x minus 1. So what you're going to do is you're going to figure out what is the common denominator because you want to cross everything off. I know if I multiply by an x minus 1 all the way across my entire equation, you have to be fair and do it to everything. I know that my x minus 1s will cross off there and there and there and there, but there exists a problem still. What's the problem? The 2. I haven't crossed off that guy yet. So that's why your common denominator will actually be a 2 as well. So I want to actually multiply everything by 2x minus 1. So that now I can also cross off the 2's. You have to multiply by everything that's there. All right, so when I cross this guy off over here, my x minus 1s are gone. I am left with a 2 and an x. So my first term becomes 2x. Okay, the problem with the second guy here is nothing crosses off, right? So you have to multiply all of that together. That makes a -4x. And you can choose to distribute it right away in your head, or you can just recopy the bracket. But I now have a 4x with an x minus 1 still kicking around. And then over here, everything crossed off, the 2 included. All I have left is that x plus 1. Okay, so that's the hard part. From here, you guys should just fly. Okay, you've done this so long. You have 2x minus 4x squared plus 4x equals x plus 1. I've just distributed. That's it. Now, like as soon as I see an x squared, I think trinomial, I think factoring, I think I need to get all of my terms on one side. So that's what I'm going to do next. I am going to minus x and minus 1 so that my right side is 0, but I have to also do that wherever over here. Okay, so when I collect all of my terms, I still only have the -4x squared. He has no pals to meet up with. But I have a 2x, I have a minus x, and I have a plus 4x. Those are all similar terms. 2x minus x plus 4x is 5x. And then I still have this lone -1 that I brought over. So there's my trinomial, -4x squared plus 5x minus 1. First thing I'm going to do is check if there's a GCF, a greatest common factor. There isn't, but I don't like a negative leading term. So I'm going to take at least that out. And now I have a trinomial. It's going to be a hard one because I have that 4 in front. So I have to do guess and check. And I pray to God that I can factor it. Because who remembers, if you cannot factor a trinomial, what's your next option? The quadratic formula. So let's pray. Let's go for it. Okay. What two numbers multiply to give you 4? 2 and 2 or 4 and 1? We got to guess. Which one do you want to go with? Which one do you want to try? You want to try 4 and 1? Hey, usually I say it's not the one with the 1, but maybe Elroy's onto something. Let's try 4. 4 and 1. So 4x times x gives me that 4x squared. What's the only way to multiply for 1? Well, 1 times 1, my last term, right? So there's no guessing there. Now we check. 1 times x is 1x. 4x times 1 is 4x. Can those two terms possibly give me my middle guy? 5, negative 5 precisely. Yes, they can if I force them both to be negative. So if I want them both to be negative, I just do that and I check. Negative 1 times negative 1 gives me positive 1, which is what I want. Very good, Elroy. Well done. It wasn't the one. It was the one with the 1. Okay. We don't have to use the quadratic formula. I am missing my 0. Oh, sorry. It's on the other side. Doesn't matter. I'm missing my 0 over here. Now I take each factor, 4x minus 1, set it equal to 0. X minus 1 set equal to 0. When I solve that, I get 1 over 4. When I solve that, I get 1. Now, not so fast. You may want to throw those in a solution set and call it a day. Not so fast. Restrictions come into play big time here, and you're going to see why in a second. You take your denominator. My first denominator was x minus 1. And you say he is not allowed to equal 0. So in other words, x can't equal 1. Your other denominator, you have to do it with both. But the good thing with this guy, your other denominator would actually result in the same answer anyway. You divide off by 2, you still get 0 on the right, you still get 1. So our only restriction is x equals 1. So we'll see that this answer we got of x equaling 1 can't be an answer because it's a restriction. So therefore, I only have one single solution of 1 over 4. Okay, last one. I've got x squared minus 3x minus 7 over 3 minus 2x equals x minus 1. I see a trinomial, so I think, oh, are things gonna get complicated? Maybe. But the good news is I only have one fraction. And when I only have one fraction, I don't need a common denominator. I know I can multiply each side by that denominator, and my fraction is gone, but I now have to FOIL on the right-hand side. That's okay. So I have a trinomial, x squared minus 3x minus 7 left on the left. And now I FOIL. X times 3 is 3x. Negative 1 times 3 is negative 3. X times negative 2x is negative 2x squared. And negative 1 times negative 2x is positive 2x. Whatever order you multiply them in doesn't matter, but that's what you should get. I see an x squared. I think trinomial. I think factoring. I need to get everything on one side. Doesn't matter which side you put your 0 on. Doesn't matter. What do you want me to do? Keep them on the left or keep them on the right? You want to keep them on the left? Okay, let's keep them on the left. Minus 3x plus 3 plus 2x squared minus 2x. I'm going to cancel, 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 cancel. Okay, so if I do the same thing over here, I have to make sure I do the exact same over here, and I got to be careful and collect all of these terms properly. So just attention to detail. I have x squared plus 2x squared. I have 3x squared. My x squareds are done. I have negative 3x, negative 3x, positive 2x. That's negative 4. I have a mistake somewhere. Do I have a mistake? Should be 8. It's negative 2x right here. Oh, my attention to detail was lacking. It's I thought it was a plus because of that, because there's a little dash through it in my defense. Okay, that's why you got to be careful. It's a negative 2x, excuse me. Okay, so negative 3x minus 2x is minus 8x. And then negative 7 plus 3 is negative 4. And my right-hand side is 0. Okay, I see a trinomial, I see a 3 in front, and I hope to God I can factor it with guess and check. Let me tell you, you can't. Or you can. No, you can't. I'm going to show you how I know. You can't. You don't have to write this down if you don't want to. Okay. There is only one possible way to multiply for 3. It's 3 times 1. That's it. There is only one, or no, there's two ways to multiply for 4. 2 times 2, 1 times 4. I'll try 2 and 2. When I check, I get 2x. When I check, I get 6x. This looks promising. Can I make a 2x and a 6x into a negative 8x? Yes, I can. If I make them both negative, make them both negative. And so many of you would just call it a day and think you got it. What's the problem? What? If I choose them to both be negative, negative 2 times negative 2 should give me a positive 4, but I want a negative 4. I want a negative 4. Those don't give me a negative 4. That's how I know it doesn't work, because of my symbols. Okay? Even if I put a 4 and a 1, it still doesn't work. So guess and check, you guys, is not working for us. So yes, you will be asked sometimes to do the quadratic formula. And I feel like it's been a minute since we've done the quadratic formula. So let's do it. This is my A, this is my B, this is my C. All right. X equals negative B plus or minus square root B squared minus 4 times A times C, all divided by 2A. So really watch your symbols there. My B is negative and my C is negative when I plug it in. Hands down, the biggest mistake with quadratic formula is symbols, every time. So now when I clean this up, negative, negative 8, I actually have 8, plus or minus. This guy will always become positive because you're squaring whatever it is, negative or positive. When you square it, it will be positive. And then what I do is I just go, what's 4 times 3 times 4? I actually just ignore the symbols for now. 4 times 3 times 4 is 48. But then I look at the symbols and I see I have 2 negatives involved. 2 negatives makes a positive. So I should have a positive 48 all over 6. Now I clean up. 64 plus 48 is 112. Ugh, I get annoyed because that's not a perfect square. I would really hope it was a perfect square, so I can square root it, but I can't. However, the good news is I will allow decimals, because technically we would be graphing these, and when we're graphing, technically I allow decimals. So even though we're not actually graphing it, in theory, this is the response to a graphing question where the two lines would cross. So I will allow decimals. So all you have to do is find the square root of 112 on your calculator, which is 10.6-ish over 6. And now you just have your two options. You have 8 plus 10.6 over 6, or you have 8 minus 10, I wrote 8, 10.6 over 6, or 8 minus 10.6 over 6. Your calculator does all the work from there. So that would be 18.6 divided by 6, which is about 3.1. And then the other guy would be 2.6 divided by 6, which is 0.43. All right. So it would be really gross to graph that, because you would have to find those decimal points on a graph. So please just don't graph. Okay, don't do it. Restrictions come from 3 minus 2x is not allowed to be 0. So I have, I'm going to send the 2 over just to make it positive. divide by 2, divide by 2. So the only value x is not allowed to be is 1.5. Neither of my values are 1.5. So 0.43 and 3.1. What? Negative. Yeah, you're right. Sorry. Negative. Nope. This one's negative. That's right, because this is negative 2.6. Sorry. Okay, 3.1 and negative 0.43 are your answers. Now, for your required questions, I'm going to pare these down because, like, you've done this before. Was today difficult? No, you've done this before, okay? So, I'm not going to make you graph any of them, okay? And on the test, you won't have to graph any of these. It'll all be algebra, okay? All right. So for 465, I want you to do 3. That's it. Just 3. Okay? There's 4 of them. 3 A, B, C, D. Is that all right? There's 4 of them. Because like I said, a lot of the stuff you've done, you know how to do. It's just the common denominator part that might get tricky. Okay, you're welcome. All right, I'm going to stop sharing now. Stop.